Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin and let's study chemistry. So, whenever we talk about acid, bases and salts, acids and bases are very easy for students considering the fact that we have only 3 reactions of acids, 2 reactions for bases, which we have discussed in the other video. But when it comes to salt and the preparation of salts and the solubility rules, that is where there are many hidden questions in the exam. You may think that this is just a simple question, but that question will have its gist in the solubility rules. The ionic equation is dependent on the solubility rules. The preparation of salts is very much dependent on the solubility rules. So in today's lecture, let's talk about solubility rules, ionic equation, and even the state symbols of equations. And then the preparation of salts. So first students, this is going to be a very short lecture. So solubility rules. This is something you have to memorize. I don't support memorization, but this is something you have to memorize. So quickly, when you know that whenever you see a nitrate is NO3 minus ion. Remember, if there is an anion of nitrate in the compound, they are all soluble. If you see a sulfate, SO4 minus 2, they are all soluble, but barium sulfate, calcium sulfate, and lead sulfate. There is a shortcut to remember, which is PCB for sulfates. Barium sulfate, calcium sulfate, and lead sulfate, they are insoluble. All sulfates are soluble, these 3 are insoluble. When we talk about chlorides, lead and silver chloride, especially silver chloride and barium sulfate are the most commonly asked questions in the exam. So remember AgCl and BaSO4. And these are also important parts of your qualitative analysis as well. We will discuss that later. So all chlorides are soluble except lead chloride and silver chloride. All potassium, which is K+, sodium, which is Na+, and ammonium, which is NH4+, salts are all soluble. There is no exception. They are all soluble. When we talk about carbonates, all carbonates are insoluble except potassium, sodium, and ammonium. We can also say that group 1 salts are soluble because they are very reactive. And lastly, all oxides are insoluble except potassium and sodium oxide. And remember, oxides are also metal oxides. And what are metal oxides? They are bases, not alkalis, because alkalis are water soluble ones. These are alkalis. Metal oxides are bases or insoluble bases. So students, from here we can talk about the state symbols. This is very important. You face 4 types of state symbols, which is solid, liquid, gas, and aqueous. So for solid, remember, solid can be metals. All metals are solids. Solids can be all of these. All of these insoluble salts, they are solids. Liquid, water, or a molten compound, as we did in electrolysis. Gases, oxygen, hydrogen, carbon dioxide, carbon monoxide, nitrogen, chlorine, fluorine, sulfur dioxide, and so on and so forth. You know many gases. Aqueous. All of these soluble ones, they are aqueous. So soluble salts are aqueous. Acids are aqueous. Alkalis are aqueous. And lastly, whenever you write an ion, they will get an aqueous state symbol. So with this, you should never go wrong with your state symbol question. These are very important to memorize, etc., for the gases, because there are many gases that you all know very well. So soluble salts are aqueous. Acids are aqueous because acids gives proton in water. Alkalis are water soluble bases, so very much soluble and aqueous. Ions, they are in water in aqueous state. Metal and insoluble salts. So remember student, there is another thing to remember. Whenever, now important part, what is a precipitation reaction? When a precipitate or an insoluble solid is formed on the product side. A solid product is formed. Precipitation is when a solid product is formed. So just look at this. Whenever you see an insoluble salt on the product side, whenever an insoluble salt is formed as a product, this is a precipitation reaction. I repeat, whenever you see an insoluble salt on the product side being formed, that's a precipitation reaction. So these solubility rules will help you a lot while determining, while studying these. Now, ionic equations. Students, do get afraid. We will just do 2 or 3 examples to make it easy for you. So, ionic equations. In ionic equations, we just talk about the ions which are undergoing a specific change. So, in ionic equations, there are rules. Solid, liquid, and gas stays as it is. They stay as it is. Now let's talk about the other one. The ions which stay the same. How same? Their oxidation state is the same and their physical state is the same. They are called spectator ions. So spectator ions are like, in a cricket match, if you're a spectator, you're not playing the match, you're just witnessing a match. So if some team wins a match, spectator has no role in that. So what will we do to spectator ions? We cancel them out. So after cancelling the spectator ions, we will get our final ionic equation. Let's do a simple example, a very basic one. Acid plus metal carbonate. This will form carbon dioxide plus water plus salt. So let's do an example. So acid, we take HNO3. Metal carbonate, Na2CO3. Carbon dioxide gas, H2O, and the salt will be NaNO3, 2 moles of NaNO3. So students, this is aqueous, this is also aqueous, sodium carbonate, this is gaseous, this is liquid, and this is also aqueous. So we are going to ionize the aqueous ones. We ionize the aqueous ones. So if we ionize acid in water, so we get H plus, balance it by 2, so 2H plus aqueous ions plus 2NO3 minus aqueous ions plus 2Na plus aqueous plus CO3 minus 2 aqueous. And here we get carbon dioxide, which is gaseous, water, which is gaseous liquid, 2 sodium ions, which are aqueous again, and 2 nitrate ions, which are aqueous. So as we said, we cannot touch the solid liquids and gases. What will we do? We have hydrogen here as a positive one. We have hydrogen in water in liquid state, so this will stay. We have 2 nitrate ions here as aqueous, 2 nitrate ions here as aqueous. Cancel, cancel. 2 sodium, cancel, cancel. Carbonate is aqueous, carbon dioxide is gaseous with no charge, so this will stay. So the final ionic equation will be 2H plus carbonate ion will form carbon dioxide plus water. The state symbols are very important. Let's do another example. It's a very important one. NaOH with sodium hydroxide plus HCl will give us NaCl salt plus water. Water is a liquid, NaCl aqueous, acid aqueous, alkali, it's a water soluble base, so it's an aqueous. So we have sodium, 1 ion, of hydroxide, 1 ion. We have 1 ion of hydrogen, 1 ion of chloride, We get, again, this is aqueous, this is going to break down. Na plus, Cl minus, water will stay because it's liquid. We cancel the Na here, we cancel the Na here. We cancel the chloride here, we cancel the chloride here. So what are we left with? H plus OH minus. Let's write the states. Aqueous, aqueous, and we are left with H2O. Let's do another neutralization reaction equation. Why am I saying that? Let's see. So H2SO4 plus calcium hydroxide. This will form calcium sulfate plus 2 moles of water. So students, let's see what the result is about. Sorry, this is the next topic that we have to discuss. But before that, acid, aqueous, alkali, aqueous. Let's not do calcium sulfate. Let's do some other example. Let's do magnesium sulfate. Why not? Because calcium sulfate is a solid. So that would change a lot. It's an insoluble salt. So calcium sulfate is a different thing. In the case of calcium sulfate, it will be a solid. It will not dissociate in water. So let's talk about magnesium sulfate aqueous. So we are left with 2 hydrogen ions plus 2 sulfate, just 1 sulfate ion plus 1 magnesium ion plus 2 hydroxide ions. Here we get 1 magnesium ion plus 1 sulfate ion and 2 water, because water is a liquid. So what do? Cancel magnesium, cancel sulfate from both sides, and we are left with 2H plus 2 OH minus, forming 2 moles of water. Can we divide both sides by 2? Oh, we definitely can. And what do we get afterwards? We just get H plus, OH minus, and a mole of water. So students, what do we deduce from here? Whenever, it's a very common thing to ask, whenever there is a neutralization reaction between acid and base, hydrogen ion plus hydroxide ion makes water. That is going to be the ionic equation for any neutralization. I just made 2 different neutralization reactions and that's what you get. So remember, you can practice for any, and likewise for any precipitation reaction. You can just write, if it's a silver chloride precipitation, so you can just write Ag ion as aqueous, chloride ion as aqueous, and AgCl as solid. So you can do it that way as well. This is the case for precipitation reaction. You should solve various examples so that the concept gets on practice for you. So now, with this, using this very concept, let's talk about the preparation of salts. When we talk about the preparation of salts, there are 3 methods. But first, there are 2 types of salt preparation. Preparation of insoluble salt, then preparation of soluble. But in the case of soluble salt, we have 2 methods. A, titration method, and B, excess method. So there is a general rule that you can remember. In the preparation of insoluble salt, both the reactant should be aqueous and the product is solid and aqueous. Both the reactant should be aqueous for this one. For titration, 2 aqueous reactants will form 2 aqueous products. Whenever they're all aqueous, the products and reactants, you use the titration method. And when the excess method, an aqueous and a solid reacts and form aqueous and aqueous. Having both aqueous means it's a soluble salt. Having solid here means it's an insoluble salt. So there are 3 different processes when we talk about the salt preparation. So this is a smart trick to remember these 3 equations. Now let's individually talk about these 3 methods of salt preparation. The steps are very important. They can ask so many things. So students, let's first talk about the first example. We have barium chloride and barium sulfate. Let's see, what do we know about barium chloride? All chlorides are soluble except silver and lead. So barium chloride is very much soluble. So this is aqueous. And we have potassium sulfate, K2SO4. All sulfates are soluble except barium, calcium and lead. So potassium sulfate is also soluble. And this will form, there will be a double displacement reaction. Barium will go with sulfate, potassium will go with chloride. So we get 2 moles of KCl, all chlorides are soluble, except silver and lead. And barium sulfate. So what do we recall about barium sulfate? That's a solid, that's an insoluble salt. So when you have an insoluble salt being made, we have to follow this process. So that's a basic one. Step 1. You have a solution of barium chloride, you have a solution of potassium sulfate. You mix the 2 solutions and the precipitate of barium sulfate, they will settle down because it's a solid. They will initially stay at the top, but they will settle down. But now our purpose is to get the salt. What will we do? We'll do filtration here. Filtration using a funnel and filter paper. The precipitate is left as residue, and this one coming down, filtrate. So residue is barium sulfate, filtrate is potassium chloride. We have nothing to do with potassium chloride, we are just focusing towards barium sulfate. So barium sulfate is the residue, filtrate is there. Now we are going to wash the precipitate with water, because obviously when you've taken it out from a potassium chloride solution, there will be drops of potassium chloride. So we just wash them with distilled water. That's pure water, just hydrogen and oxygen, no dissolved salts. So we just wash the precipitate and we then dry it with a paper towel or filter or oven. So that's what we do when we have the preparation of insoluble salt. Let's talk about the soluble ones. Soluble ones, the first one is titration. Very important for P4 especially. So as I told you, both should be aqueous. So for instance, NaOH plus HCl, we did talk about it. They're all aqueous. They will form NaCl plus water. So aqueous liquid, this is aqueous, this is aqueous. So we are all dealing with liquid medium. So in this case, it's a titration method. What will we do? We will have NaOH solution, we will have an HCl solution in beakers. We will pipette out. Pipette is a 25 centimeter cube. You can use the alkali or the acid to pipette out. So if I pipette out sulfuric acid, I will add sulfuric acid in a conical flask, and then I will add an indicator. Indicator will help me find the change in pH. It will tell me the end point. What's the end point? When all the acid in the conical flask has been neutralized with all the alkali in the burette. So this will tell me that this is the end point, the color has changed, stop the reaction. And we can note the reading in burette. So let's see. Then we will use a funnel. We will transfer the alkali in the burette and we will add drop-wise alkali in the acid so that we can see the color change. The indicator has a specific color in acid, specific color in alkali. We will keep on adding it. And when there's a color change, we stop. We take the reading from here and we repeat the experiment. Students, because here we have our NaCl. But let's say it's a pink NaCl. Have you ever seen a pink NaCl, which is a table salt? No. Because there is the indicator impurity in there. So that is why we're going to repeat the whole experiment, but this time without the indicator, so that we can get a pure result. It's a colorless solution, but we don't need any color change because we have the endpoint value from the burette. So we have the endpoint value. We will just add a specific amount and we will get the soluble salt here. This is the soluble salt. Okay, the example was of sodium sulfate. Again, it's the same thing. So what will we do next? We're going to put that into a china dish. We're going to evaporate it. We're going to crystallize it. Crystallize or evaporate to dryness. In the next step, I will talk about those steps. But remember, whenever it's an important, it's 6 mark P4 question. Whenever they're both soluble, they're both aqueous, we use titration method. Lastly, excess method. What do we remember about the excess method? For the excess method, remember, one needs to be solid. One of the reactant needs to be solid in the excess method. So that's what we're going to do. Let's say we have copper oxide plus H2SO4. So this is also a neutralization reaction. Why? Because this is a metal oxide. Metal oxide is a base. It's not an alkali. This is an acid. This is also a neutralization reaction, but do not get confused between titration and neutralization. Titration is different. Titration is for acid-base soluble neutralization. This is an insoluble neutralization. Or I can have any metal carbonate here, because metal carbonates are also insoluble, or just a metal, because these are solids, right? So what do we get with copper oxide? We get copper sulfate and we get water. So let's see. Okay, there we have an example of zinc plus H2SO4. We get zinc sulfate and H2 gas. Let's call it zinc oxide, but chalo. So we have added zinc in the sulfuric acid. As long as we keep on adding zinc, the zinc will react with sulfuric acid and it will form zinc sulfate, which is again aqueous. All sulfates are aqueous. So zinc sulfate will keep on forming. So zinc sulfate is forming. But after a time, when all the H2SO4 has been used, no more zinc sulfate will be formed. The added zinc will start settling down at the base, just like this. This means that zinc powder was in excess. This is the excess method. But our aim is to get the zinc sulfate. We don't want zinc powder. What will we do? Just simple filtration method. We filter it out. Excess zinc is the residue and zinc sulfate is the filtrate, which is the salt we need. Now we are also going to wash it with filter water so that the zinc crystals, if they have any of my zinc sulfate droplets on them, they will wash it out to this solution. Because I don't care about water, I have to evaporate anyway in the next step. Let's see what we're going to do here. We put that zinc sulfate solution here. We put it in the evaporating dish. We heat it. It becomes a saturated solution. We let it dry. And after some time, the crystals of zinc sulfate settle at the base. And we use the glass rod to see what happens. So this is a saturated solution. It is not going to further evaporate. So we filter it out. We just filter it out. We filter the zinc sulfate crystals because the crystals have been dried. This is crystallization method as well. This is evaporation to dryness as well. So excess method is also called crystallization method. But crystallization is also done in the previous one, which is after this step, we do the crystallization there as well. So we add the zinc sulfate crystals here, but do we wash them now? Will we wash the crystals now? No. Why? Because zinc sulfate is water soluble. If you put water, it's going to dissolve it again, then do the crystallization and evaporation again. So just pour it out and you get pure crystals on your filter paper, and that's the difference between the three methods. And for these three methods, students, you need to know solubility rules. In the last October-November P4, there was an important question as well. But there was an important question, but there was a silly mistake. They were like, do a neutralization reaction between insoluble copper oxide, between copper oxide and sulfuric acid. But the students forgot that copper oxide is insoluble. So that is why if it's insoluble, they should use this method. But a few students use the titration method. So you need to be very mindful of selecting the method. But for that, the key is solubility rules. So thank you so much again for being here with me. Allah Hafiz and best of luck.